Hi everyone, my name is Augie. I'm the creator of the world's first working black hole model. Yes, at last, we have a working black hole model that actually mimics the real thing. It is absolutely amazing, incredible, and unlike anything ever before seen. It's quite the breakthrough, I'm going to dare say. In the past, we've had the usual models that consist of 3D images, some computer-generated simulations, and artist impressions, among others. And despite these being very good, they do not exhibit or show you the behavior of the black hole. In a sense, you can say that they're very Newtonian-like. Well, I was not quite satisfied with these particular models. I was convinced that out there somewhere, a living model was tucked away. Something more along the line of the general relativity where things play out and flexibility is observed. So I started to search for this particular model. I went through the usual places, planetariums, museums, universities, large and small, space agencies, national and international, and I searched through many other places, including very large, technologically oriented organizations that had emphasis in astrophysics. Upon finding nothing, I really thought to myself, how is this even possible? How can there not be a living model of a black hole? So I thought maybe I should give it a shot and perhaps create one. Well, of course, the fundamental forces, we have not conquered gravity, and that's the no-brainer, right? How are you going to create a black hole without artificial gravity? So anyways, after many months of critical thinking and imagination, I finally came about a way of mimicking gravitational fall. I'm not going to claim that I've cracked the code of gravity by any means, but I have devised a very particular effective method of causing gravitational fall from a particular point, not towards a point. But it is a method that that wherever you set that point, that's the point where gravitational demand comes from. So let's just say, for example, there's a free-falling mass here on Earth, and this particular method is close by. You will definitely see a deviation in this fall, or you will see this fall absolutely fall horizontally, or it will simply be deviated to this point. Yes, absolutely amazing. And as a matter of fact, if there is mass underneath the point of singularity, this mass will fall upward. It is unnatural to see. It is very bizarre. It just is. So, of course, I can't get into the details as to how, but this was a huge struggle. Many times, many times, I just felt like just giving up, just give up and do something else, because it was mission impossible. So anyways, the curiosity just kept me coming back to it until I got it. Now, of course, that was the greatest challenge. This particular model is very unique in its presentation as well, because the point of singularity does not lay over a fabric. You can almost say that this is a freestanding model within its own housing, so that we can observe not only what happens on the top, but also the bottom and all around. So very, very unique. The point of singularity has to have a centrifugal force to it. So by developing a method of causing this centrifugal force, the spin, I essentially succeeded in combining the two fundamental forces of the black hole. Now, the capacity of the spin is near 30,000 RPM, so it is very, very fast. And of course, it requires a like a bullet resistant or bulletproof viewing glass within its own housing for safety, of course. So as you can see, this is a serious model. Now, I'll be posting some pictures or maybe some short videos of some of the points of interest as we go along. When I first started testing this model, the first thing that I tested was the establishment of orbits. I've created these mock stars and just put it inside the model, and lo and behold, these mock stars established orbits around the black hole. Now, this is a great time to tell you that there are no screens, there are no special effects, no wires or magnets. There is absolutely no software involved. So these orbits are established by means of the forces exerted by the host and the mass of the particular mock star. And of course, these can go on indefinitely. So I was very, very happy to see that these orbits were absolutely independent and requiring no other assistance per se. So I was very, very happy. And honestly, I really thought that was going to be the extent of this model. You know, I kind of thought, okay, this is probably the end of the road now. But something occurred. There was an accident at the shop, and while I was doing some testing, and I remember that all of a sudden an accretion disk formed. And I'll never forget, I was just standing there mesmerized and in disbelief. It seemed like a cruel joke being played on me. It just seemed unfair that this characteristic would present itself in such a manner. You know, I was just mesmerized. I was speechless. After the accretion disk occurred, you know, I kind of thought, well, you know, I just got lucky, and this is probably the extent of this model. So I did something very, very daring, just to kind of prove to myself that was it, you know. I thought to myself, what if I do a light bending experiment? And I thought to myself, okay, this is going to be the end of the road. Well, I did this light bending experiment, and this black hole is absolutely capable of bending light. It was absolutely amazing. Another unbelievable moment. You know, I just don't have the words to express the disbelief in my own eyes of the things that I was observing. I remember thinking, this is starting to add up. Things are actually starting to come about. So something is right. So I became a little bit more confident, and I thought to myself, okay, let's do another test. Let's test spaghettification. Now, in the past, before this model, I just knew that the way that spaghettification and the loss of mass of stars to a black hole was misrepresented. I just knew that, a star doesn't just hang out over here and then the black hole creeps up and then in a very clean aesthetic way starts to remove its mass, and then it swirls and swirls down and goes down like a sink per se into the black hole. I just knew that was not the way it actually happens. So I conducted the test, and of course the process of losing mass is very messy. It's absolutely messy. There's a lot of a lot of mass that becomes dispersed, and it clouds the actual event. That's why it's so difficult to get in the picture these occurrences in the real life with Hubble and such. Well, the process of spaghettification absolutely did occur. Like I said, it was very messy and kind of difficult to track. When a star comes too close to the black hole, the immense gravitational fall combined with the immense centrifugal force, this causes the star to just really stretch out as it's trying to escape and fall at the same time. And it starts to wrap itself around the black hole. There are twofold results here. The first one is the actual spaghettification of the star, where it becomes wrapped around the black hole, and you get to see the entire process of the dissemination of the star, how it loses its mass, the way that mass falls through the event horizon is undescribable. We'll get into that. It's a little bit deeper stuff, but as this event is occurring, one is able to actually observe the spaghettification process from start to finish. The second fold part is very exciting to me, because recently a group of scientists released the first picture of the black hole. Now, of course, I've had this thing here for a while now, so I was really hoping that things would match for us, and I must say that all credit goes to these folks who are extremely smart and being able to overcome the challenges to take a picture of a black hole. Of course, it's very unfair because I have cameras that can come up close to, my model and take good pictures. But anyways, the second fold is the event horizon, because during spaghettification, the hot plasma of the star is very reflective, and you can see the contour of the event horizon. Let's take a quick look at a picture of one of my photos of the event horizon right there. The hot plasma is surrounding the event horizon, and you can see the contour of it. Very exciting to observe with your own eyes. I'm going to take this moment just quickly to make this mention. When one makes these observations through this model, it is somewhat similar to, say, witnessing the Grand Canyon or the Niagara Falls, where the experience actually requires you to be present to see with your own eyes. There are some details there that just cannot be transferred or conveyed through high quality picture or high quality video. You have to absolutely be there to observe. And some of these very important aspects are lost when they're being represented through media. So the contour of the event horizon, the manner in which mass falls through it, very different from what is theorized or represented in media. But nonetheless, very, very exciting. I mean, just try to imagine that you've discovered the Grand Canyon there for the first time, or the Niagara Falls per se. So, okay, so tell you what, I'm going to show you a very, very short, very brief, I know it's kind of unfair, but this is just an introduction. I'm going to show you a very brief video of a star that came too close to the black hole, and some of the mass that was ejected falls back towards the black hole, while the majority of the existing star was already being spaghettified. A very short clip. Let's take a look at that. Yes. Oh yes. Yeah. And unfortunately, you just can't see some of the other characteristics of the mass, how it behaves in this particular environment. But this is an absolutely exciting clip to show. I have no words. I have no words. Okay, so another characteristic of the black hole is the jets. Yeah. This black hole model is capable of creating jets. Now, at this point, they're not quite perfect, and I am actually not going to be showing you any video or pictures of these. I do apologize, but the way that the jets are formed are very different from the common belief out there. So this one I'm actually going to reserve showing, but it does create the jets. So just once again, just really happy to share with you this introduction of the black hole model that I have put together. I really hope that you've enjoyed this video. Once I get some clearance as to what I can or can't post, then I will update with maybe some actual video footage. And believe me, it's going to be some really good stuff. Okay, until next time. Goodbye.